This problem gave us a lot of words, but it all boiled down to this. Given something called the variance, which is a function of p, f of p equals 50 times p times parenthesis 1 minus p, that was given to us, that equation. Find the p value which maximizes this variance. Well, look at the solution. If you think of p as x, it's easy to see what's going on here. Think p is the same as x in, say, f of x instead of f of p. So then we will have, given f of x equals 50x parenthesis 1 minus x, find the x value, which is max. Okay, so first, there's two methods. There's method A, which is completing the square, and there's method B, which is using a formula found in your textbook. Okay, so let's do method A first. We've got f of x equals 50 times x parenthesis 1 minus x. Distribute that multiplication, you get 50x minus 50x squared. So f of x equals negative 50x squared plus 50x. Okay, so factor out the coefficient of x squared. Got to pull it out of everything in the parenthesis. And that's negative 50 times x squared minus x plus half the coefficient of x, which was negative 1 squared, minus the same thing squared. Now carefully pull the negative guy out. You've got negative 50 times x squared minus x plus negative 1 half squared plus, it's actually plus 50 times negative 1 half squared because we had to pull out the factor of negative 50 with it. So we've got negative 50 times factor this x minus 1 half squared plus what's left over at the end, 50/4. So that's negative 50 times x minus 1 half squared plus 25 halves. So model this after our standard a times x minus h squared plus k. Thus we see that a is equal to negative 50. That's a negative number. That implies the vertex will be our maximum point. We're looking for a maximum x value. So hk here from the equation that we got is 1 half comma 25 halves. So the maximum x value is the h. H equals is positive 1 half. So p equals 1 half is the p value that maximizes the variance. That's method A. Now what about method B? Here we use a formula. Here we have f of x equals negative 50x squared plus 50x as before. That's ax squared plus bx plus c. So the a value is negative 50. That means it's negative, and that implies the vertex will be a max point as before. So our vertex hk, well, the formula is that h is negative b over 2a and k is f evaluated at h. So we only really need this x value. It's the maximum x value. So x equals negative b over 2a, so it's negative 50 over 2 times negative 50 because b is 50 and a is negative 50 above. And that simplifies to 1 half. So p equals 1 half is the p value that maximizes our variance. Method A or method B, your choice.